Today now we are going to start with a new lesson, lesson 8, the last lesson in our chapter, which talking about probability of compound events. In this lesson, we are going to learn how can we find the probabilities of mutually exclusive and overlapping events and the probability of independent and dependent events. Now, in the previous lesson, we deal with one outcome. We say that how many, as an example, what is the probability of rolling number 3? What is the probability of rolling or of tossing a head? If I have only one outcome, I call this event simple event. So a simple event is an event all with a single answer. Today now we are going to deal with more than one outcome, with 2 or 3 outcomes. If we have now more than one outcome, we call this event compound event. So compound event is a combination of 2 or more than one event. Such as if I have like number cube, and we know that the outcome on the number cube is 1, 2, 3, 4, 5, and 6. Now, if I tell you now what is the probability of getting number 3, what did you tell me? We have only 1 3, so you say 1/6. So this here, the probability of getting a 3, we call it simple event, because I only have one outcome, which is number 3. But if I'm asking you now, what is the probability of rolling an even number and greater than 3? Yalla, think about
5/6.
Even number and greater than 3. How many numbers are even? We have
3.
2, 4, 6. But I want them greater than 3. So 4 and 6. So how many outcomes here we have?
2/6.
2 outcomes. Since we have 2 outcomes, we call this event compound event. And today now we are going to deal with the compound event. We have more than one outcome. So the compound event combines 2 or more events. How can I combine between 2 events? By using word and word or, such as probability of getting 3 or 5 as an example. The probability of getting 3 and 5. Now in this lesson, we are going to see how they are different. So to combine 2 events, we have to use and or. Now, I told you here that if I want to combine between 2 events, I can use or. So if I want to use or, I will classify my compound events into mutually and non-mutually, or we call it overlapping. So if I want to use word are, I can classify the events into mutually or non-mutually. And if I want to use or to combine them between and, I will classify the events into independent and dependent. So in this lesson now, we are going to learn the 4 types of compound events: mutually and non-mutual, of mutually and overlapping. Mutually and overlapping if I use or, and if I use and, I can classify them into independent and dependent. Now let's start with the first 2. Let's start with the mutually and non-mutually. What's the difference between them, and what is the meaning of mutually and non-mutually? Let's start now with the mutually exclusive. Mutually exclusive, it's 2 if we have 2 or more events cannot occur at the same time. I mean, like, there's no common outcomes. Such as an example that every time, remember word that every time I remember it, maybe you know it, like to be, sorry, or not to be. To be or not to be, this is here just to remember that you say, I will be in grade 8 or I will not be. Yani I will be in grade 8 and or I will be in grade 9. But I cannot be in grade 8 and in grade 9 at the same time. This is here, you will call it mutually exclusive. That means that the 2 events cannot happen at the same time. I cannot be at grade 8 and grade 9 at the same time. Either grade 8 or grade 9. So mutually exclusive means that we cannot have 2 events or compound events happen at the same time. We call it mutually exclusive. Now in overlapping here, no, it can be. We have 2 events and it can be happen at the same time, and we have one outcome, and we have an outcome. Like as an example, to be at grade 8 or at another school. Yes, I can be, because grade 8 is at another school. So I can be. But to be at grade 8 and our grade 9 at the same time, you cannot. You have to be in grade 8 or grade 9. So mutually exclusive means that 2 events cannot happen at the same time. And since they cannot happen, there's no common outcome. But in overlapping, yes, they can happen at the same time, and we have an outcome. This is here the difference between them. Remember every time, to be or not to be. To be in a place or not to be. You cannot be in the place and don't be in the place at the same time. So mutually exclusive means that cannot occur at the same time, and there's no common outcome. The overlapping can happen at the same time, and they have one outcome. Now, let's see what is the formula of the mutually exclusive. Now, mutually exclusive, the formula of it will be A, probability. Since we have A or B, that's mean here we have 2 events, events A and events B. This is an event. A, and this is now event B. Now, if I want now to combine between them, as I told you, one of the ways to combine between them by OR. And for OR, we can now classify them into mutually or non-mutually. The formula for mutually will be probability of the event A plus the probability of event B. A plus B. So let's take an example now. How we said that this is mutual. As an example, if you have now the number cube and you have the outcomes are 1, 2, 3, 4, 5, and 6. And I want you now to give me the probability. Let's say that event A choose a number greater than 5. And event B choose an odd number. Now, the probability of A or B. Here, what's the number that's greater than 5 or odd?
Number greater than 5 is 6, and odd is 1, 5, and 3.
Yeah, so let's now draw here the circles. Let's imagine. So, event A choosing a number greater than 5. What are the numbers greater than 5? They are 6. And odd number 1 or 3 or 5. Now, is there here a mutual event? Is there here an event that they are the same in A and B? A number that they are the same?
No.
Here, greater than 5, yani number 6. And odd, 6 is not odd. So here, these two events cannot happen at the same time. Cannot we have greater than 5 and odd? Yes. So we have to say here, this is a mutually exclusive. So the formula of the answer will be probability of event A plus the probability of event B. What is the probability of getting a number greater than 5? How many number we have greater than 5?
1.
1. Plus, how many number odd?
3/6.
3/6. So the answer will be 4/6. Here, you cannot say that this number is greater than 5 or odd. This is a mutually exclusive, means that there's no common outcome. Is it clear? And later on, we take more example, you will understand it more. Is it clear?
So teacher, here the mutually exclusive, it's 6. So, I will consider it that it is 6.
No, here ask yourself. Is there a number that is greater than 5 or odd at the same time?
Here in the possible outcomes, no, only 6. It's greater than 5, but not odd.
Yeah, there's no yani. When you ask it, so here, if you have C word or, ask yourself, is there a number that's greater than 5 and odd? No. Yeah, could be 5, or you could be odd or greater than 5. But there's no number are common between them. So I will say that this is mutually exclusive.
Okay, miss.
Wait a minute, I will give you now more examples, but let's see now what is the overlapping events. Overlapping now, if you look at the Venn diagram, the overlapping means when here it's not with you, here it's mean R. Here it's mean and. Now, the probability of A over B, now here we have two events and I want to combine them with R. But here now we have an mutual events or common events, such as rolling a number that is even and greater than 3. So now, let's see here. Here we have the number Q, 1, 2, 3, 4, 5, and 6. Now, if I ask you now, what is the probability of getting number or rolling a number that is now, the first case here, we have two events, rolling an odd number and rolling 2. So now, if I want now to represent it by the Venn diagram, you have to say that here we have two circles. Now, odd numbers, they are 1 or 3 or 5. Or 2, I mean, choose number 2. Now, is there a number can be odd and 2 at the same time or 2? Number 2, number is 2 and odd.
No.
No, because 2 is not an odd number. So this event here, we say that this will be mutually exclusive. And since it is mutually, the formula will be the probability of A plus the probability of B. Then, what is the probability of event A? How many outcomes here we have?
3.
3 over how many numbers?
6.
6, bravo, plus the probability of event B of choosing number 2. How many outcomes we have?
1.
1, bravo, here we have only one outcome, over 6. So the answer will be 4 over 6. Now let's go to the next example here. For the next example now, here now, even number such as 2, 4, and 6. And then and number 2. So here now, this is the two events. Now, is there a number could be even and 2?
Yes, miss.
Yes.
Miss, number 2.
So here there's a number that is mutual. Let's make the circles like this now. This circle here means that a number, this number here, this here, that means there's a common outcome. And yes, actually there's a number, can be even and can be 2. So the answer of the formula we'll use will be the probability of event A plus the probability of event B minus the probability of A and B. Now, what is the probability of event A? How many outcome in probability in event A, sorry? How many outcome we have? 3, bravo.
Yes, 3.
And how many
3 over
outcome
6.
in event B? Getting number 2, how many outcome?
1.
1.
1 over
Bravo.
6.
By now, is it okay? Now, minus probability of A and B. That means what is the number that is common between these 2 events? What is the number that is even and 2?
2.
Bravo, number 2.
2.
So I mean here we have only one outcome. So minus 1 over 6. And the final answer will be 3 over 6. Is it clear now?
Yes, Miss.
Inshallah, when you talk more example, you will understand. But mutually cannot happen at the same time. And even and non-mutually or overlapping, yes, it can happen. And there's a common outcome between them. Yeah, get back here. So here now, as you see, the probability of mutually exclusive events, A or B, will be probability of A plus probability of B. And here in the probability, the science of probability, be careful that or it's mean plus, or it's mean plus, and it's mean multiply. Or is plus and is multiply. So A or B will be probability of A plus probability of B. And if we are overlapping, if there's a common factor, we have to say probability of A or B will be the probability of A plus the probability of B minus the probability of A and B. Let's go now to take more examples. Here, we have now, suppose you spin a spinner that has 20 equal sized sections numbered from 1 to 20. So here now we have a spinner, and the spinner has the numbers from 1 to 20. So you know what is the spinner? It has 1 from 20. So what the numbers in the what the outcome numbers will be? 1, 2, 3, 4, 5, 6, 7, 8. They tell me that's numbered from 1 to 20. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here, this is a spinner. It has a number from 1 to 20. Now, so what the outcome will be? Choosing any of these numbers. And by the way, this is a theoretical experiment. Now, what is the probability that you spin number 2 or 5. Spin. 2 or 5. Now, how will you solve it here? Ask yourself first, if you see word or means it could be mutual or overlapping. If you see word or, remember, it could be mutual or overlapping. Now, 2 or 5. Ask yourself now, can I choose number 2 or number 5 at the same time? This is the spinner. Here, this is the spinner. It has numbers from 1 to 20. Now, when you rotate the spinner, can the number stop, or your finger as an example, stop at number 2 and number 5 at the same time? No. No, exactly. Cannot stop at 2 and 5. So, because we cannot stop at 2 and 5 at the same time, we have to say this will be now a mutual exclusive events. Because the spinner cannot stop at 2 and 5 at the same time. So the probability of A plus the probability of B. Now, what is the probability of getting A? Where's A? This is A, I mean. And this is B. So what is the probability of getting A? What is the probability of getting number 2?
1 over 20.
1 over 20. Because how many 2 here we have?
Only 1, 2.
Only 1, 2. Bravo. Plus the probability of getting number 5.
1 over 20.
Bravo. 1 over 20. So the answer will be 2 over 20. So here you ask yourself, can I choose number 2 and 5 at the same time? No. So this will be now a mutual exclusive events. Now, for the same question here, what is the probability that you spin a number that is a multiple of 2 or 5? So here, now what you have to do, you have to draw 2 circles. And we have 2 events. Events A, choose a number that is multiple of 2. And event B, choose a number that is multiple of 5. From the numbers 1 to 20. Now, yellow, what are the numbers that are multiple of 2? We have 2, 4,
6, 8,
8,
10.
10, 12, 14, 16, 18, and 20. Now, multiple of 5. 5,
1,
10, 15,
10, 15,
and 20.
20.
Now, if I want now to combine between these 2 circles, is there a mutual number?
Yes, 10.
Yes, 10. Yes, 10 and 20.
Bravo,
20.
10 and 20. So here, number 20 will be mutual, and number 10 will be mutual now. So from here, this is an event A, and this is now an event B. Now, so what is the probability of getting A or B? يعني getting a number that is a multiple of 2 or multiple of 5. And here, first, before solving it, you ask yourself, is there a number that is a multiple of 2 and multiple of 5?
Yes.
Between 20 and 10. So I have to go now to use the formula of overlapping events. Probability of A plus probability of B minus probability of A and B. Then, what is the probability of event A? How many numbers in event A? Let's count them. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Don't forget the numbers here. So how many numbers in the event A?
10/20.
10/20. Bravo. Plus the probability now of event B. 1,
4/20.
2, 3, 4. Bravo. So we have 4 numbers. They are multiple of 5. Now minus numbers that they are multiple of 5 and multiple of 2 at the same time. What are these two numbers?
2/20.
10 and 20. So we have 2 numbers only. So we have, then you have to add 10 plus 14, 14 minus 2, 12 over 20. Is it clear now?
Yes.
So I will stop here now. Here, sorry. Tomorrow, inshallah, we are going to talk about the independent events.
Okay.
Just a second, please.